In this video, we'll talk about function notation. We use function notation to denote that y is a function of x. So we write it like this, y equals f parenthesis x. So the way we would actually read that is y equals f of x. This notation means that y is a function of x, or that y depends on x. For this reason, y is called the dependent variable and x is called the independent variable. So think of dependent variable as output and independent variable is the input. When we evaluate functions, we're going to look at function notation, such as example 1. Let f of x equal 7x minus 3x plus 1. In order to determine f of 1, that means we're going to substitute 1 for the x value back in the function. So it would look like f of 1 equals 7 times the quantity of 1 squared minus 3 times 1 plus 1. So anywhere I saw that variable of x in the function, I'm substituting the given value, positive 1. On the left side, this function notation f of 1 is simply function notation. We're not doing anything with f of 1 except copying it each time. Remember, that is not multiplication. It is function notation. It tells us we are evaluating the function when the x value is 1. Now think back to order of operations. We need to do the exponent portion first. So that means 7 is multiplied by 1, because 1 squared is 1. And then we have negative 3 times 1, that's negative 3. And plus 1 is our last term. Now we need to do multiplication before we do any addition or subtraction. So f of 1 is equal to 7 times 1, which is 7, minus 3 plus 1. So 7 minus 3 would give us 4, plus 1 more would give us 5. We can represent this answer now as an ordered pair. The input value was positive 1, so that would be our x value, or independent variable. The output was our answer of 5, so that's the y value. I can represent my answer as the ordered pair 1, 5. Let's determine f of negative 2. So the function will be evaluated with an x value of negative 2. That means 7 times the quantity of negative 2 squared minus 3 times negative 2 plus 1. So I do the exponent first. That means 7 will be multiplied by the quantity of negative 2 squared. So that means negative 2 times negative 2, that's positive 4. When you have a negative number squared, the result is always a positive product. Next, we have negative 3 times negative 2. That would be positive 6. Last, we have addition of 1. 7 times 4 would give us 28, plus 6 plus 1. So when we add those numbers up, 28 plus 7 more would give us 35. The ordered pair represented by f of negative 2 would be x value of negative 2, and then our output, or y value, is 35. Finally, we're going to determine f of 0 for this given function. So f of 0 would equal 7 times the quantity of 0 squared minus 3 times 0 plus 1. So that would be 7 times 0 minus 0 plus 1. So it looks like this first term, 7 times 0, would be eliminated. Minus 0 is eliminated, and so it looks like all we have left is 1. So f of 0 equals 1. The input was 0, output is 1. So we have the ordered pair 0, 1. What you will notice now is that we have 3 ordered pairs that were generated with this function notation. This is going to be very useful to us a little bit later in the semester, and we know how ordered pairs are useful to plot on the Cartesian coordinate system, and we could see what this function actually looks like. But we might need more than 3 ordered pairs to see the full picture of this function. In example 2, we have a new function, and that is f of x equals negative x squared plus 2x plus 7. So we have to be extra careful when there's a negative out in front of that quantity. To determine f of 1 would equal a negative times the x value squared. So I'm automatically going to place a parenthesis set any place where I have my variable x. So you can see that the negative is outside of the parenthesis, not included with the 1. Next we have plus 2 times the x value of 1 plus 7. So when I start to evaluate, positive 1 is what we square. The negative outside is not part of the squaring. So I have to keep that negative, and it's now multiplied by 1 squared, which is 1. So that final product does turn out to be a negative 1. Next, 2 times 1 is positive 2, and we're adding 7 at the end. Negative 1 plus 2 would give us positive 1, add 7, that would make 8. So our ordered pair, input was 1, output is 8. Next we'll determine f of negative 2. So we have our negative times our quantity squared. This time notice that the substitution for x is a negative number. So be sure to include the negative in that parenthesis. Then we have plus 2 times the x value of negative 2, add 7 last. So we keep the negative that is outside of the quantity, square that quantity of negative 2. Negative 2 times negative 2 would make positive 4. Next, 2 times negative 2 would be negative 4. Last, we're adding 7. Negative 4 minus 4 would give us negative 8 plus 7. So that total is negative 1. That's our output. So the ordered pair we generated had an input of negative 2 and an output of negative 1. Finally, we'll determine f of 0. With f of 0, we'd have a negative times the quantity of 0 squared plus 2 times 0 plus 7. So we know that 0 squared is 0. 0 multiplied by this negative 1 is still 0. That term eliminates. 2 times 0 eliminates. So it must mean that f of 0 is equal to 7. The ordered pair generated here had an input of 0 and an output of 7. In this last example, we're going to determine function values from a graph. In example 1, we're looking for f of negative 2. Remember, with this notation, it is f of x. So that tells us the x value must be negative 2. So looking at the x-axis on this graph, negative 2 is located right here. And we can see the ordered pair is given as negative 2, 0. So negative 2 is our input, 0 is our output. So when we evaluate f of negative 2 by looking at the graph, that simply means find the x value of negative 2. What is the corresponding y value? Next, f of 1/2. Well, that might be a little more difficult to look for because we're counting by ones on this graph. So f of 1/2 would be this dashed line, and we are not given the ordered pair. So notice we do have the equation. We can do a substitution like we did on our last example. So let's write this a little bit larger. Y equals 2x plus 4. That's what's given to us. So if we're looking for f of 1/2, our x value is 1/2. So when we make the substitution, that means y equals 2 times 1/2 plus 4. 2 times 1/2 could be 2 over 1 times 1/2. Well, look at the reducing here. Everything in this first term reduces to 1, so 1 plus 4 means the y value is 5. So f of 1/2 equals 5. F of 2, here's an x value of 2, and we can see that's already a given ordered pair on the line, so that corresponding output is 8. So if you have the actual equation given, you can use the substitution technique, and that's what we had to do for f of 1/2. But when your x value is actually given as an ordered pair on that line, you can simply use the output that's already given. For the next example, we're going to determine these function values using the given parabola. F of -2 means x value is -2. So here's an x value of -2, and it looks like I need to go up 5 units. So I could name this ordered pair -2, 5. So that means the corresponding output or y value is +5. F of 0 means I'm looking for the x value of 0. And we go down, here's where we find it at -3. So 0 for x, go down 3 for y. The output is -3. Looking for f of 3, you can see it's right here on the graph. So we went 3 units to the right, but then we didn't need to go up or down anywhere. So 3 units to the right corresponds with 0 for the y value. Now we'll talk about finding function inputs. In example 1, we're going to solve f of x equals 0. So if we're given the function f of x equals -3x plus 9, that means we are setting the whole function equal to 0. So f of x is replaced with 0 and set equal to -3x plus 9. Notice this time we were given the output of the function. In the last several examples, we had the input of the function. So if our f of x is set to 0, that says the output is 0. If we solve this equation now for x, we could find the corresponding input. As far as an ordered pair is concerned then, if output is 0, that means the y value is 0. If we solve for x, we'll be able to find the input that corresponds with that output value of 0. So I'll start by subtracting 9 from each side of the equation. -9 now equals -3x. Just using our properties of equality, I can see division of -3 would solve for x. -9 divided by -3 would make +3, so +3 is our x value. That's going to be substituted in the ordered pair, so 3 is the input, 0 is the output. In example 2, f of x equal to 0 means the output is now 0, equal to the function x squared minus 9x plus 14. Notice this is a quadratic or a second degree x, so we'll need to use some factoring technique to solve for x to get the input. Again, we're thinking of output is 0, what is the input? And since it is a power of 2, we're probably going to have 2 ordered pairs. So that means 2 different inputs for x. So let's see. X squared is a perfect square. Unfortunately, 14 is not. So we'll probably have to go to sum and product in order to factor this problem. So sum, remember, comes from the middle term, -9. Product would be 1 times 14. So that would be 14. Let's try 2 times 7. 2 times 7 makes 14, but when I add 2 plus 7, I get +9. So do you see all that we have to do is make 2 negative and 7 negative, so that 2 negative numbers still have +14 for the product, but 2 negative numbers added together will match the sum, which is negative. So we'll replace our middle term. 0 now equals x squared minus 2x minus 7x. Keep +14 for that last term, and we're ready for grouping. So even though we've talked about factoring in a previous lesson, You'll see how important it is now that we're dealing with functions. 0 now would equal common factor of x times a quantity of x minus 2. So probably we need a quantity of x minus 2 for this second grouping. Working backwards, x times what factor would match negative 7x? That would be negative 7. Is negative 2 times negative 7 14? That looks good. So now we have 0 equals our common factor of x minus 2 multiplied by our other factor, x joins with minus 7. We just need to set each factor now equal to 0. That means x minus 2 is equal to 0 and x minus 7 equals 0. This is our 0 factor property. Addition of 2 will solve this for x equals 2. And here, adding 7 to each side, we have x equals positive 7. These are the input values. So the two ordered pairs we just generated would become 2, 0 and 7, 0. So if we ask what was different about these two evaluation procedures? Well, the first example was linear, so we could just solve for x. But the second example was quadratic. It had this power of 2, so we had to use factoring.